everyone, very good afternoon all of you and welcome to Unified Study. Yes, all of you are ready to do the mind mapping. Everyone is ready. After doing the computer architecture and operating system together, now today we will do DBMS. Here all the confusion, all the mind mapping will be done. All the confusion will be clear. And there will be no problem. All this problem I will resolve here, and definitely you can confirm your marks, definitely. And it is the expected area from where you can get 10 marks comprehension type question. All this area we will do here today. Now yes, all are present. I can see Anbu, Monica, Bhuvana, Lisa, Lopa, Prathiva, Senthil, Lekka, Vamohan, Karthika, Full Moon, Ashwini, Nazreen, everyone, Rubia, Lopa, Rubela, Manisha, Angry Bird, Nandini. Yes, definitely it is helpful for GATE. Why not? Definitely, because in the GATE also syllabus is same, and I am covering GATE questions also. I am not covering only UGC NET, I am covering GATE questions also, and always I am teaching as per the level of all the exam. I am not focusing only on UGC NET exam, I am focusing on all the computer science exam. So definitely this will be helpful to you. Okay. And just as I told already, after completion of this UGC NET exam, I will start the GATE previous year's question, only GATE, focusing on GATE question, focusing on GATE exam till the February. That will be going on in this channel. So definitely everything will be helpful for you. Yes. Okay. Thank you. Chalo, let's start. So first of all, whenever we are going to start the DBMS, these are the always important part of DBMS, that is functional dependency, normalization. Always confusion are coming among the student. Lossless, lossy, dependency preserving. Always confusion are coming, and always questions are also coming from this topic. ER diagram. That is also area of confusion of the student. What is 1 to many, many to 1? What will be the minimum number of table? And after that, next topic is coming like that. In SQL, so you are getting scared. My God, how to do SQL? Transaction concurrency, serializability, view serializability, acid property, different types of transaction protocol. These all are there in your DBMS, and everything we are going to cover here. Everything. All the things we are going to cover here. Okay. So let's start without wasting time. From your basic to advanced, everything we will do. Yesterday we did the computer architecture, and now we will do the DBMS. All the DBMS topic is ready for you. Just quickly we will do the revision. Okay, quickly we will do the revision from here. See that. I am going to start from beginning. Yes, from here. Okay, so here first of all, there are three tier architecture in DBMS. 3-tier architecture. Why it is important? See that whenever you are using any system like the Unified Study app, we have the app that is Unified Study app. Those who are not using this till now, definitely use it, because there are so many free mock tests available for you. Each and every subject wise mock test is available for you. Okay, so must use it. And I will take the example of Unified Study app only, so that you can do the mind mapping, that how actually database working and why this is the requirement of different level. This is the first concept of database, that is external level, conceptual level, physical level. So what is going on here? Here the first point is the physical level. In the physical level means what? Physically we are storing data. That is the physical level, right? Physical level means where we are storing the data physically. That is the physical level. So physical level is the location of the database object in the data store kept where actually we are storing the data. When you are trying to see the student table, employee table, course table. Normally there is the student database. In the database we are trying to see that. But actually where? In the hard drive. Yesterday we learned the computer architecture. In the computer architecture we will do the mind mapping of all subject, I told. So you learned that secondary memory, primary memory. So somewhere the database is stored. Somewhere the database is stored. So how it is stored and in which area this is stored, that is your physical level. Okay, how data is being stored into the secondary storage. Where it is stored? In secondary memory. Yesterday we learned, right? So in secondary memory we are storing the database. That will be the physical storage area. Next one is the conceptual level. Now what is conceptual level? Conceptual level means you are able to conceptually you are able to understand, means you are visualizing the database. We are representing as a table. There will be this many attributes, this many data, we are representing it, right? So when you are conceptually represented, the data represented in the form of various database table, how you are representing it, that is your conceptual level. So student database may contain the student course table, what the table will be, how many table will be, that is the conceptual level. Next level is the external level. External level means different user have different view. That is the external level. Okay, that is the external. Ma'am, I have not completed crash course fully. Can I join paid PYQs? It's your choice. It's your choice. Now though there are only more 4 days I will take the class. After that there will be recorded version will be only available, because class will be going on till 5th. After that class will be end in that course. Okay, now it's your choice. So here external level specified the view of the data term. That is means I am the admin. Whenever I am taking the class, my view is different. In my view, whenever you are attempting mock test, I can see all the student, what is your performance, what is your name, what is your roll number, what is your phone number, and what when you attempt the mock test, what is your performance, everything I can see. My admin view is different. And when you are using it as a student view will be different, right? So different user type is trying to see that in a different way. That is the external level. So external level means each external level view is used to cater the need of the particular category user. According to your requirement, the data you can view the database. According to my requirement, I can view the database. That is the external level. These are also important. From here also questions are coming. Now the topic is, so I think these 3 levels are very clear. These 3 levels are very clear. There will be no doubt. Yes. Mind mapping. We will do one by one. Every total subject will be like a mind mapping. This 3 level you are able to understand. Right? Data independence. What is data independence? There will be no dependency between each and every level. There are 3 levels. In the 3 levels, there will be no dependency. Okay. So data independence means the changes of the data, one level should not affect another level. One level if you are doing, then in another level it should not affect. That is the data independence. Okay. Physical data independence means physical location of the table and the index should not be affect the conceptual level. Main thing is that there are the layer. Here if you are coming to this layer, that will be clear. You can see this is your external level, user 1, user 2, user 3, different user have different view, and between external label and internal label, this is the conceptual schema. This is the conceptual case schema. This is conceptual level. This is your internal schema, and ultimately this is your physical database. This is the first topic of your database, that is the three-tier architecture. Three-tier architecture, and here the presentation tier, application tier, and database management tier. Okay, this is the starting of your database. And what are the benefit of the three-tier architecture? Scalability, flexibility, security. From the first chapter also questions are coming. From the TOC, if you all are interested, maybe tomorrow I can take. Maybe tomorrow I can take if you all are interested. Let's focus on DBMS now. And TOC though it's going on, right, Manisha? We already did in morning class, evening class also we will do in the paid course. So that's why try to manage the all subject together, because very less time we have to do revision, right? That's why. So here chord rule in DBMS. What are the chord rule? Chord rule are also important nowadays. Questions are coming from chord rule. How many rules are there? 12 rules are there. What are the focus of this rule? The focus of this rule is how your database will work. The basic some rule you have to do. What are the basic rule? There will be, whenever you are storing the data, then first rule is the information rule. All the information, whatever data I am storing, that is the user information. User information or metadata that stored into the database must be entered as a value in the cell of the table. Like that, here is the table, right? In the table, whenever you are doing that, the name. So, what is the name of the employee A? B. What is the roll number? 1, 2. As a value we are going to store. This is the information rule. From here questions are coming, guys. Don't ignore this topic also. Okay. Next one is the guaranteed access rule. Guaranteed access means database is giving you guarantee. What guarantee? The guarantee is that each data element is guaranteed to be accessible logically with the combination of table of name, primary key and all. Means whenever you are trying to select, you will do select star from student. Means you are trying to access that. So you will be able to access through what name? Select employee name from employee. So employee name is the attribute name. Through the attribute name you can access the data. That is the guaranteed access rule. Next thing is the systematic treatment of the null value. Why the systematic treatment of the null value is required? When we are using null value, when any data is not there, you are storing any database, at that time you are going to enter the data of employee. Now employee name you know, employee roll number you know. Maybe till now employee department is not allocated. Just now you assign the employee and within some time it will be allocated, but till now it's not allocated. At that time what we can do? We can put null value at that area. So whenever you are using the null value, this null value is also very important. The systematic treatment, that uniform treatment, that anywhere, anytime, anyhow you are using null value, that will be not correct. With the correct way you should use the null value. Okay. Active online catalog rule. What is that? Nowadays so everything is online. You are also learning online. You are using so many apps. You are using so many websites. So you are using the database also. So that's why the database catalog, which contain the metadata about the data. Catalog means what? Whenever you are going to any restaurant, whenever you are going to any shopping mall, everywhere you are asking for a catalog, right? Give me a catalog. you are going for any company or anywhere you are going to visit, so they are showing a catalog, through which catalog you are able to see what are the available things are there. That is the data about data, means metadata. Data about data, that is the metadata. So the catalog rule must store and access using the same relational database management system. This is the active online catalog rule. Next one is the comprehensive data sublanguage rule. Comprehensive data sublanguage rule means what? DML, data manipulation language, because throughout the database you have to manipulate the data, like insert data, update data, you are trying to delete data. These are the data manipulation, right? So whenever you are doing the manipulation of the data, then manipulation should be in a correct way. This is the DML, understandable data manipulation language, that facilitate the query, because in SQL we are writing in, it is very similar to English language. If you are not able to understand that language, how we will write it? How we will write the query? That's why this is the level rule 4. Rule 5, viewing update rule. The view update rule. We can create the view of the database also. Original database is there. This is a huge big database. Out of that, some of the part I want to show to the user. That is called the view. So view that theoretically updatable, also updatable in the system. We are able to theoretically update the view, means view is not a physical existence. There is no physical existence of the view. But theoretically, if I am trying to update the view, then it should reflect the original physical level also. That is called the view update rule. Next one is the high level insert, update and the delete. Whenever you are doing the insert operation, delete operation, update operation, it should affect the original database also. It is not like that temporarily you are doing something and original one is not affected. Physical data independence, just now I told that application program that activates should remain the unaffected when changes are made by the physical storage. In the application level, it will be not affected. Logical independence, the application program activities remain unaffected when changes are made by logical level. That is the logical data independence. Okay. Next one is integrity independence. Integrity means what? What is the meaning of integrity? Integration. You are integrating all the data together. So integrity constraint means separately from the application program, store the catalog. Different database are there. Now all the database are integrated together. Then also it should be independent, that one is affected then other will be not affected. Distribution independence. When you are storing the data in a distributed pattern, you are storing database here, this is here also, distributed pattern. Whenever you are storing it, then distribution of data across the multiple location should be invisible to the user. Nowadays, whenever, whatever app you are using now YouTube, right? Do you think YouTube is using only one server? YouTube is not at all, Google is not at all using only one server. You are fetching the data from that server what is very close to you. Definitely we are in India, and for that there is the server in India. We are not using the USA server. Definitely not. But are we able to understand that from which database you are able to access it? Not. This is not. You are not able to see. But that transparency is there, right? So you cannot understand. And last one is the non-subversion rule. Non-subversion rule means if the interface of the system is providing the access to the low level record, like all the record everyone cannot access. every user have the limited access. So if you are able to access the low level record, then interface must not be able to damage the system by passing security. It is very important. I am giving you some access of the low level, some specific level I am giving you access, and you should not be allowed that okay, you are able to access that and with that you can actually affect the original database. That will be not possible, and that security should be always there in the database. So before starting the database, these code rules are very important to understand that how I should handle the database, how a user is using the database, how a admin is using the database, and what are these rules. You learn this 12 rule. Are you able to remember this 12 rule? Write down in the chat box what are the 12 rule you learn. Questions are coming from here. What are the 12 rule you learn? Tell me. What are the 12 rule you learn? Tell me in the chat box, everyone. What are the 12 rules? Tell me. I explained already. Rukaiya, I already explained. Sathiya, information rule. After that, next rule. Think like this way. Think like this way. Remember like this way. See that. Remember like this way. First, you are, why anyone is coming to your system, think like that you are running a website. You are running the website. Why the user will come to your website? To get the information from the website. So first rule is the information rule. And whenever they are using your website, that is you are using the Unified Study app, Unified Study website. So I have to give the guarantee of that. Yes, you can access that. Guaranteed access should be there. If you are paying the money in our paid course, after that you are not able to access, then is it okay? You pay the money 500 and now our paid course is going on at 500 rupees. You pay the money of 500 rupees for accessing all the PDF, for accessing all the recorded class, all the live classes. Now after that you are not able to access that. Is it okay for you? Not definitely. So there should be the guaranteed access also, right? Systematic treatment of null value. If there is some problem, some classes are not there, some problem is there, some data is not available, should I show that to you that this data is not available or something, or I should treat it is a proper way? So I should treat that in a proper way, that null value systematic proper way we should handle it, right? Active online catalog rule. Think like that whenever you are visiting the Unified Study app, you are trying to open the catalog, like what are the courses are available. That is your catalog. So you will see that what are the courses are available for you after visiting the system. First thing is that. Okay, so that is the catalog. Next thing is the comprehensive data sublingual language rule. That is how you are accessing the data. DML language, that is manipulating the data. You are able to communicate, you are able to understand the language of the system or not. If Unified Study is written in French language or German language, you will be not able to understand anything, right? It should be written in a common language what will be understandable by everyone. That is the comprehensive sub-language rule. After that, viewing update rule. So whatever you are able to view means you are able to, whenever you are attempting the mock test, you are submitting the mock test. It is in your view you are submitting. If after submission of the mock test you are not able to see the result, maybe you did 10 question correct, but in your result it is showing that 0 question correct. Is it okay? No, because whatever view you are able to see, that should be updated also. So that is the viewing update rule. High level insert, update, delete. Whenever I am inserting any course, I am updating any course, I am deleting any course, it should be affected in the original one. I have deleted that, but still it is showing. I have updated it, data, I have updated a PDF, I upload a PDF, but you are not able to see. It is not like that. From my end I am able to see means definitely it should be uploaded in the database also, that you are able to see the database also. That is the updation. Next level is the physical independence, logical independence. That is, everyone should be independent. There should not be any dependency between anyone. Physically there should be independence also, logically also it should be independent, integrity independence also should be there, distribution independence should be there. These are the 4 types of independence: physical, logical, integrity and distribution. Last one is non-subversion rule. That is, any subversion, whatever my employees, I am giving someone that okay you should insert this data. When someone is, I am giving the test series okay to someone, yes please upload this test series. At the time of uploading test series, if he or she is deleting my all courses, is it okay? Is it okay if he or she is deleting all the courses? This is not okay, right? So that's why non-subversion rule, the sub part, the employees of my company should not delete, should not access, should not break the security of my system. That is the non-subversion rule. These are the rules. In this way you should remember, relate with the original thing, yes, how it is going on. In this way if you are able to remember, then all these rule you will be able to remember easily. Information rule, guaranteed access rule, systematic treatment, null value, active online category, these all the rules are there. Clear? And as per sequence also, if you are not able to remember, in the exam hall whenever they are asking that yes what is the which one is not the chord rule, like this type of question, then also you can do it. Clear? Is that clear to everyone? Yes. Clear? Chalo. Now next one is the type of database. What are the type of database? Hierarchical database, network database, object oriented database, relational database, non-SQL, no SQL database. These are the different types of database available on market, what we are using. From here also question came, that is hierarchical database. Hierarchy, we are showing like a hierarchy, category, subcategory wise it is showing, right? Category wise we are dividing. That is hierarchical database. Here is the university, department, administration, student, faculty, resources. You are category wise you are showing. That is the hierarchical database. Next one is the network database. Here you can see this is the hierarchy is there, and with that another one is also connected. That's why it is called network database. Network database is a hierarchical database, but major tweak means 2 part is connected here or 3 part is connected here. They are making a network. The child record are given the freedom to associate with the multiple parent. It can associate with the multiple parent. So it can associate with the club also. It can associate with the department also. That's why it is called the network database. And remember this line, the child given the freedom to access with the parent database. From here question can come. Next one is the object oriented database. Just like the object oriented programming, you are also by means in the object oriented programming we are showing that member function, member data, like that. Same way, this is the person, name, phone number, email. Here it is the function, these are the function, these are the attribute. Like this way I am representing. That's why it is called the object oriented database. It is able to relate this model of the database easily. Information stored in the database is capable to being represent an object which represent the instance of the database model. It came from the object oriented database category. Next one is the relational database that normally we are using as a relation. One table is related to another table. This table is also related to another table. How? Using primary key and foreign key concept. That is the relational database. Last one is the NoSQL database, is nowadays very popular. That is a flat system. Here no table, nothing. NoSQL originally referred the non-SQL or non-relation, no like table format, nothing. Database that provide a mechanism to storage and retrieval of the data. The data model is totally flat system. Okay. So here it is simpler horizontal scaling to the cluster of the machines and finer control over the availability. Till now we are habituated with the table wise data, but NoSQL is not storing like table wise or the relation wise. Okay, it is more flexible. So here are the advantages of NoSQL. There are many advantages working in NoSQL like MongoDB, and here mainly nowadays we are using for the Hadoop, NoSQL, big data. This concept are very trending topic, right? Now you can see here is a question: which of the following database model we have a parent-child relationship? Can you tell me what will be the answer for this? My video stuck, right? Can you tell me what will be the answer for this one? Why my video is working, right? Yes, answers are coming. Here those is what telling network database. It is, we have the parent-child relationship. In which database? In relational database, parent-child relationship is not there, only in hierarchical and network database, that is A and B. Okay. Yes. Now come to the functional dependency chapter. Very important chapter, functional dependency, because ultimately we are working in relational database, that is RDBMS, where everyone is depending, functionally depending. One key is dependent on another key. That is the dependency, right? Whenever you are telling that key, it is a big thing, like about a big university or big college. There you are trying to find out a student. So how we will be able to find out? You will go to that college and you will call Priyanka, where is Priyanka? You will be able to find out Priyanka. In a college, definitely there will be at least 20 to 30 Priyanka. Definitely 20 to 30 Priyanka will be there. Now how to find? You have to know that in which department Priyanka is. In that department, which year? Maybe you have to say computer science department, maybe the first year student. After that also, in first year computer science there are two Priyanka. Which Priyanka? You have to say the roll number. Yes, the roll number of that Priyanka is this one, or the student ID. Through that how you can identify, right? So to identify any data, it's required the functional dependency, because the name, through the name you cannot identify. There should be the key. Through the key there should be a key, which key can identify all other attribute. That is the concept of functional dependency. Okay, that is the concept of functional dependency. Okay, yes. So now you can come to this one, that in the functional dependency. Here these are the things: attribute, tuple, table, relation schema, degree, cardinality. These are the concepts, are very important concept. Attributes means, here I am coming to this one. Yes, these are your attribute: customer ID, customer name, status. These are your attribute. Okay. Okay, thank you. These are your attributes. This is the primary key, right? These are the key. And domain, what is the domain? Domain means here you have to insert something, not null. Means data cannot be null, that is you are specified. Here column are called the attribute, that is the degree of a relationship. Degree means columns, and cardinality means rows. Very important. Rows are called cardinality. Degree means that is the column are called the degree. Okay. Yes, here whenever you are coming to functional dependency, I will tell you the very easy things, and after that you will never confuse about functional dependency. How to identify the dependency like this: A implies B is hold or not. How to identify? Think like that. Here is roll number 1. Here is the roll number 1. And here is the name. Okay. So roll number 1 name is Priyanka. Roll number 2 name is Priyanka. Roll number 3 name is Priyanka. Is it possible or not? Is that possible or not? Tell me. Roll number 1 also Priyanka, roll number 2 also Priyanka. Is it valid or not? Is it possible? There is in the class all are Priyanka. It's possible? No problem. I cannot say it's invalid. By chance all are Priyanka. It is possible because Priyanka name is very popular. Now here this is the okay. This is possible. This is possible. But is it, why not? Why not? Why not possible? All are Priyanka. It's possible. Why not possible? It is possible, no problem. Think logically. Logically, is it possible or not? Yes. Name should be different. Why? Where? I learned from college, from school to college, there are so many Priyanka. Everywhere, whenever I am going, my name is also Priyanka. In school also, there is, in every class there was Priyanka 2, 3 Priyanka was there. And everywhere, whenever I went for any competition, my name is also Priyanka. I was making friendship. Oh, your name is also Priyanka. Please make the friendship. It is not mandatory in one class. Is it like that? I took one student name is Priyanka. I will not take any other student. You are going to take an admission. So maybe another student name is Priyanka. And that college can reject you. No, we have one Priyanka. We will not take another Priyanka. Is it okay? Definitely not. Definitely not, right? They cannot reject you. Yes. But tell me that, is that possible? The roll number, is that possible now? Roll number 1 name is Priyanka and roll number 1 name is Nazreen. That is the last name, Nazreen. Is it possible? Is that possible? Roll number 1 name is also Priyanka. Roll number 1 name is also Nazreen. Is it valid? Anyhow, is this valid? In a class, there will be 2 roll number 1. Roll number 1 is all Priyanka. Roll number 1 is Nazreen. This is never possible. This is never possible. Means what it is? Whenever you are checking the data, left hand side, check the left hand side and check the right hand side. Just come to this example. A implies B, hold or not. Here is A, here is B. Check all the data of A, check all the data of B. First of all, check the left hand side data. Is there any repeating data? If there is no repetition, then no problem. Because roll number 1 is Priyanka, roll number 1 is Nazreen, that is not possible. But roll number 1 is Priyanka, roll number 2 is also Priyanka, roll number 3 is also Priyanka, that is possible. So there is no problem with the right hand side, problem is coming with the left hand side when left hand side is repeating data. You have to check is there any repetition. You can see A1, repetition is there. As there is repetition, so same value should be there for B. It is telling A1 is giving B1 and A1 is giving B2. That means roll number 1 is Priyanka, roll number 1 is Nazreen. That is not possible. Anyhow, this is not possible. That's why it will be not valid. That is the reason it is not valid. Here is A2, A3, A4, A5. No problem. These are all different data. But whenever in the left hand side there are same data, here it should be, this is B1 means it should be B1. It cannot be B2. It cannot be B2. Right? Clear? This is the way you have to identify the functional dependency. Easy and simple. Clear? Now tell me A implies C, is it hold? A implies C, is this hold? Is it holding here? Tell me quickly. A implies C, is it holding? Here you can see A1 in the C, C1 is there, here is C2. Not. How it is hold? Nazreen, you are telling hold. I call your name, you are telling hold. How? Here to my name is C1, A1 is telling here A1 is C1. How A1 can be C2? Not possible. Left hand side same values means in the right hand side also same values should be there. A implies D, is it holding? A implies D, is that hold? Is this holding? A implies D. Is this holding? A implies D. Yes, here is A1, here is D1. Here is A1, here is also D1. A1 is going to the same value D1, D1, no problem. Other than that, these are different value, no problem. When there are different value, then no problems are there. Got it? Clear? I hope it is clear to everyone. This concept is clear to everyone. Now tell me what will be the answer for this one quickly. Tell me what will be the answer for this one. Answer. What will be the answer? Tell me the answer. Tell me the answer. Okay, here is the here what is going on. All of you are telling C, 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 C. Those who are telling C, they are wrong. Here it is asking which one not hold. Which one not hold? Which one is not holding? So you can see B implies C. If I am telling 2, 2 is here, 3, 3 is here. That is holding here. All are holding. Why you are telling 3? BC implies A will not hold because here 2, 3 together, 2, 3 together. But for this 2, 3 here is 1 but here is 4. If it is 1 then it is okay. Here is 4, that's why it is not okay. Right? Don't do the mistake in the not in the question. Don't ignore the not. Please, please. This is the trap. This is a big mistake. Not, incorrect, false. These statements are very, very important for your exam. Please don't ignore it. If you are ignoring it, then you have to see not qualified. Is it okay? Is it okay? Always tell yourself that if I ignore the not, incorrect, false in the question, then I have to say not qualified. Do you want to see the not qualified? Then don't ignore it. If you don't want to see, then please don't ignore it. Okay? Please don't ignore it. Now tell me what will be the answer for this one. After that I will go to normalization, because if your option, what option? Option 4 told do this one. Do this one. It was asking not, Benita. It was asking not. Which one is not? Here AC implies C. If you are taking AC together, why you are getting confused? AC together, think it. This is 1, 2, this is 4, 2, this is 5, 3. All are different data. All are different data. When all are different data, then there is no problem. All are different data. Where is the problem? Tell me what will be the answer for this one. Those who are watching and you forgot to click on like button, please like, share, subscribe and try to make, I want to see one thing. You can do it. When I will end the class, this before ending, subscribers should be 20k. Before ending the class, subscribers should be 20k. Can you make it? You will be able to make it. In your room there are so many mobiles are available. In every room we are now in 928. 19,928. So those who are live now, try to make the subscriber. When I will end the class, then there should be 20k and we will celebrate 20k with you. Can you make it? Can you make it? I think you can make it. I think you can make it. It's possible. I think you can make it. In your room there are so many mobile available. Right, you can make it. So here it is asking you what is the functional dependency hold for above instances. Hold for above instances. What are the hold? Here the B implies A. Is it holding? Here is the B, here is the A. 1, 1, this is 8. 2, 2, this is 10. No problem. It is holding. A implies B. Is it holding? Yes. 8, 8 for 1, 1. 10, 10 for 2, 2. This is also holding. A implies C. A implies C. A implies C means here 8, 8. That is this one. Not possible. This is not possible. A, B together 8, 1, 8, 1. Different data. That is also not possible. So definitely answer is this one. I hope this functional, how to identify the functional dependency, this is clear to everyone. This is clear to everyone. I hope so. Yes. I hope so. Yes, there are 93 students I can see. So in your mobile, in your home, there is your father mobile, mother's mobile, your parents mobile, your husband mobile, your wife mobile, all the mobiles are there. So do the subscribe for from all of your mobile in your home. Subscribe to the channel from all mobile in your home, from all friends of your area. Do it. Make subscriber more. So super key, candidate key and primary key, there is the mostly confused. Students are getting confused, right? So here why you are getting confused? Because what is called candidate key? First of all, what is candidate key? Candidate key is that who is able to identify other attribute, who is able to identify the other attribute, that is called the candidate key. Okay, so now I will ask you a question, how to do that, who is able to identify the other attribute, how you can understand? Because just now whatever data here in this table only, can you say what is the candidate key? Which one is the candidate key? Can you tell me which one is the candidate key here from this table? Can you identify the candidate key? Can you tell me which one is the candidate key here? How to identify? Candidate key means the attribute which is able to identify other attribute, means the dependency is holding. Through the table I am telling you. Which one is the candidate key? What I have to say? I have to think about A. A can identify B. A can identify C. If A can identify both, then A can be my candidate key. Then A is my candidate key. So A is able to identify B. A is able to identify B, yes, because here is 8811, no problem. A is able to identify C, no, here it is not holding, right? B, can I say B? B is also not able, B is able to identify A, that is okay. B is not able to identify C, it is not possible. Now come to C. If I am coming to C, C is able to identify A. Here is 14, 16, 16. For 16, 16, these are different data. So not possible. So A, B, C, any one of them is not my candidate key. Separately. Now take combiningly. Now take it combiningly. How to take combiningly? A, B together. Is it possible that A, B together can identify C? 8181. Not possible. It is also not possible. Think it about B, C together. Is it possible? Is it able to identify this one? Is it possible? Try to see that. Where was the problem? With the 16 and 16, 14 and 14. 14, 1, 16, 1, 16, 2. 14, 2. These are all now different. BC if you are taking, then all are different. See that this is 114, this is 116, this is 216. These are actually different data now. This is 214, this is 114, different data now. So BC implies A, that is correct. So means which one is my candidate key? BC is my candidate key. Is it or not? BC is my candidate key. Yes, this is the way from the table you have to identify the candidate key. Everything you have to check which one can identify all other attribute. So BC can identify the candidate key. Yes, no ma'am, why not? Why not? Rukaya, please concentrate. All are different now. 114 together. It is different. 214 also different. 116 that is different. 216 also different. and 240, 15 all are different. In the left hand side BC all are different. BC implies A. BC can determine. So here BC will be my candidate key. Okay. Why? Yes, it is possible. BC implies A is possible here. Right? So BC implies A is possible. And AC, is it possible? AB, AC तो already we did. It was not possible, because if I am taking AC, think it 8, 14, 8, 16. It's okay. 10, 16 okay. 10, 14 it is also different. They are also different. So AC implies B, that is also holding. 8, 14, 8, 16, 10, 16. For the 16 they are different data. For 8 they are different data. For 10 also they are different data. So AC implies B, that is also candidate key. So what are my candidate key? BC also my candidate key. AC also my candidate key. Right? Why I can say these are candidate key? Because only B is not a candidate key. Only C not a candidate key. Only A not a candidate key. This is the minimal one who can identify other attribute. That's why these are my candidate key. In a one table, multiple candidate keys are possible. Got it? Yes. How to identify candidate key, is that clear? And what is called candidate key? This is the minimal set which is able to identify other attribute where the dependency is holding. Only one A, only one B, only one C was not possible. That's why this is minimal set. If it is like that, only one A can determine B, C, then it is not possible. Then this will be not possible. Okay. Now, then what is my super key? What is my super key? What is my super key? Super key is candidate key plus something extra. With the candidate key, whenever you are adding something extra, that is called super key. Means BCA, that is a super key. ABC, this is a super key here. Got it? Because candidate key plus something extra, that is my super key. That is my super key here. Okay. What is my primary key then? What is my primary key? Any one of them. They both are the candidates, selected candidate as primary key. Whenever there is the voting system going on in the election, there are so many candidates, those who are selected. Out of them, only one prime minister will be there. So many candidates are there, those who are selected in the vote. But after that, only one will be the prime minister. Same thing is there. There can be multiple candidate key. Out of them, any one of them will be my primary key. Any one of them will be my primary key. That is, either BC can be also primary key or AC can be also primary key. Any one of them can be my primary key. Got it? Clear? The concept? What is primary key? What is super key? Any one of them can be here my primary key. Clear? Yes, so that's why the candidate key is the subset of the super key. This is the subset of the super key, and out of the candidate key, any one of them can be my primary key. Clear to everyone? I hope so. Then now tell me what will be the answer for this one. Yes, it is possible. Yes, it is possible. Debolina, I am coming to your answer. It is possible. Just like the superset, whenever you are taking the superset, the set itself is also there, right? If you are coming to the superset concept, the set itself is coming. That is also coming under superset. That's why the candidate key itself will be also there. Answer everyone. Yes, answers are coming. Again some students are doing mistake 4. Again the question was that here it is asking which one of that not the candidate key. Which one could not be the candidate key? Could not be the candidate key. So here you can see that first of all check B. If I am checking with B, then B is all are different value. Whenever all are different value, then there is no problem. All are different value means there is no problem. Definitely B will be A, that is also correct. B to C, that is also correct. B to D, that is also correct. So B is my candidate key definitely. Whenever B is the candidate key, then BC is my super key. BC definitely my super key. Right? So that's why definitely my answer will be this is not the candidate key. Because BC is the super key here. And that's why your answer will be this one. Got it? Clear? Here just now Debolina was asking that number of possible super key in the database. Any subset of the attributes in a table is equally identity all the tuple of that known as the super key. Okay. So here it can be this one is also the super key. It's the different of that the primary key and candidate key in sense that is minimal super key. Candidate key or primary key will be also possible, that is also a part of super key. Okay. So means we remove all the attribute that are unnecessarily or uniqueness, only becomes the primary key or candidate key. So all primary keys or candidate key are also super key, but not all the super keys are primary key or candidate key. I hope your doubt is clear, because it is also the subset. This is also the subset. Okay. So here this is a question you can see from this example. Let these are the attributes. Out of that A1 is your candidate key. Then how many super keys are possible? How many super keys are possible here? Total to the power 2 to the power n minus 1 super keys are possible here. There are. Okay. So 4 super keys are possible. What are the super key? A1 itself is a super key. A1, A2 together is a super key. A1, A3 is a super key. A1, A2, A3 is the super key. These all are my super key here. That's why here total 4 super keys are possible. Okay, clear? Your doubt is clear, I hope. Chalo, now go to the next. Yes, here is the some next concept is there. There are different types of integrity constraint. What are the types of integrity? This is very important. domain integrity, entity integrity, referential integrity and key constant. These are the different types of integrity constant. Okay, question can come from here, and check that example. Domain integrity, when we can say this is domain integrity, you can see here in the age you are putting a, that will be not allowed. This is one example of domain integrity. Entity integrity, here you can see in this example, here you are not putting anything. Employee ID is the primary key, but you are giving null. Primary key cannot be null. That is your entity integrity. Took the example, remember the example, very important. Next one is the referential integrity. What is the example of referential integrity? Here you can see this is the foreign key. Okay, so from where I am taking? From the department number. Here 11, 24 and 13, these are the department number is available, but 18 anyhow you cannot take, because ultimately if this is the foreign key, what is available in that relation, that is only possible. Any other one you cannot take. So 18 cannot be possible here, because here in this table 18 is not available. In this table 11, 24 and 13 is available. That's why it will be not possible. What is the key constraint? 101002, not allowed, because key should be always unique. Candidate key means key should be always unique. Multiple same value, this is also 1102, this is also 1102, that will be not possible. Here is also 1102, here is also 1102, not possible. This is the example of key constraint. This type of example they can give you, it is what type of constraint, and you may be getting confused and you will do the mistake. Okay, so here this chart will help you for the integrity constraint. Questions are coming from here. The referential integrity constraint, you can see that here in the reference, at the time of insert, whenever you are inserting data, then there will be no violence in the reference table, but in the referencing table it can cause violation. Why? Because think about that, there is the employee table and there is the department table. In the department table, DID is the primary key here, but in the employee ID, DID is the foreign key here. Other than that, here employee ID is there, that is the primary key. Now think logically, if you are inserting anything in the employee, then is it violating any problem? Is there any problem in the violation? In the referencing table, is it creating any problem? If you are inserting, it will create the problem, because you have to take the department ID from here, right? But if you are inserting anything in the department table, then there will be no problem, because new department you are adding, there is no dependency with the employee. So that's why here is no violation. This is the department table is the reference table. Reference table is the department table. Referencing table is the employee table. This is the reference table, this is the referencing table. Okay, clear? So that's why here whenever I am deleting, then you can see in the delete, on delete, there will be the problem, because if you are deleting the data from the department what is already referenced here, then it can create problem. But if you are deleting employee, then no problem is here. If you are updating anything, then also it can cause the violation, because here is the department number 1, now you are making department number 10, then it can cause the violation. This table is very important for your exam, where the violation is there. Okay, clear? is that clear to everyone? Yes. Pakka? Can I ask question? Pakka? So then let me ask you a question. Tell me what will be the answer. Tell me what will be the answer. Those who are watching, please like, share, subscribe. Please try to make more subscriber. Share with your friends, family and everyone. Answer me. Good evening. Good evening. Tell me the answer. What will be the answer? Tell me that. Okay, answers are coming. Yes. So here whenever you are deleting 20, 40, 20 and 40. So from the 20, 40 if you are deleting, then you have to see actually the employee number 20 is deleted. Now you have to check where the employee number 20 is the manager. Here employee number 20 is the manager. That's why you have to delete this one also. Now again, employee 35 is deleted. Where employee 35 is the manager. Here employee 35 is the manager, so that's why you have to delete this one. Now employee 30 is deleted. Now anywhere 30 is the manager? No. Here is 40, here is 45, here is 25. So no need to delete. That's why what are the extra row? This one and this one should be deleted. That is 30, 35 and 35, 20. This should be also deleted. Got it? In this way you can get the question. Now come to the next topic. The next topic is normalization. This is the next topic where till now so many students are getting confused, and I am telling you the easy trick of normalization, and with that easy trick you will be never able to forget. You cannot forget. You cannot forget the normalization after learning this. So here how to do the normalization. Let me take A page. At the time of normalization means what? The all types of constant till now you learn, integrity constant, domain constant, key constant, so many constants are there. So you have to maintain all the constant. After maintaining the constant, you have to, whenever the table is there, then table should satisfy. There should not be any problem. Okay. So whenever you are checking BCNF, you are checking the BCNF. This is the first one you have to check. Other than that, there are 4NF, 5NF also, but checking is coming till BCNF. Always start with the BCNF, because if any table is in BCNF, then it will be in 3NF also, it will be in 2NF also, it will be in 1NF also. Automatically it will be satisfied. So always try with the higher one. Whenever you are trying with the higher one, then for BCNF simple rule is that all left hand side should be candidate key or super key. Simple one. Check all the functional dependency. Check all the functional dependency. And then check left hand side should be left candidate key or super key, and it's fine. If it is not there, then it is not in BCNF. After that, come to 3NF. Very good, Jivita, Rukaya. 3NF. What to do? If this is not satisfied, then find out the prime attribute and non-prime attribute. Now ma'am, what is prime, what is non-prime? Prime attribute means the part of candidate key. You have to find out all possible candidate key. Any relation whenever it is given, then from there try to find out all possible candidate key. After that, try to find out the primary key, the prime attribute. And what are the non-prime attribute? That is not the part of candidate key. Not the part of candidate key. That is called the non-prime attribute. Okay. Now in 3NF, transitive dependency is not allowed. Transitive dependency not allowed. What is the meaning of transitive dependency? Simply remember, non-prime to non-prime will be not allowed here. Check if there is any one what is non-prime to non-prime, that will be not allowed in 3NF. And that's fine. Now if it is not satisfying, then come to 2NF. In 2NF, non-prime to non-prime will be allowed. But which one is not allowed? Partial dependency is not allowed. Partial dependency will be not allowed. Okay. What is the meaning of partial dependency? Prime to non-prime. Prime means part of candidate key. Don't do mistake here. Sometimes students are doing mistake. A is the candidate key, then A implies B, B is the non-prime. They are thinking prime to non-prime. Don't do that mistake. If it is completely candidate key, when there is only one attribute as a candidate key, then no chance of partial dependency. Remember that. Partial dependency is possible when candidate key is a combination of more than one attribute. If there is only one attribute, so that is the candidate key itself. That is not a prime. Prime means part of candidate key. So only partial dependency possible when there is the more than one attribute in the candidate key. If there is only single attribute in the candidate key, anyhow partial dependency will be not possible. And always it will be in 2NF. Don't do mistake here. Here so many students are doing mistake. Ma'am, this is the prime. No, that is candidate key. It is not the prime. It is the full candidate key. Partial dependency means part of candidate key. Okay. Finally, to 1NF, always all the relation normally it will be in 1NF. This is the simple thing you have to remember for normalization. Is that clear to everyone? Till now, anyone have any doubt in normalization? After teaching so many times, still some students are facing, ma'am, I am not able to understand normalization. Simple way think it. These are the steps you have to remember, and after that nothing will be required. Clear? And all possible candidate key you have to find. You have to find all possible candidate key. If you are not finding all possible candidate key, then your answer will be wrong. So then if it is clear, then tell me. Then tell me the answer. How many candidate keys are there? Tell me how many candidate keys are there. Both the answer you have to do. You have to tell me the answer for part 1 also, part 2 also. In this way only you can get the comprehension type question. You have to tell me the part 1, how many candidates keys are there, and part 2 is that what are the candidate key, what are the candidate key, that is also number of candidate key, the name of the candidate key also you have to mention, and the part 3 is there, the relation is in which normal form. All this you have to tell me. 1, 2, 3. How many candidate key? What of the candidate key? And it is in which relation? It is in which normal form? And the set of prime attribute. What are the prime attribute and what are the non-prime attribute? So this is the question number 1, 2, 3 and this is 4. All that you have to do. Do it, I am coming. 4 question. All that you have to do. Do it, I am coming. Okay, answers are coming, I can see. Okay, candidate key, normal form, all are coming. Okay. So what will be the answer? Here first of all, these are all my relation. Out of that, how to find out? That is very simple. How to find out? CH implies Z, A implies BC, B implies CFH, E implies A, F implies EG. Check it in the right hand side which one is not present. Check that in the right hand side which one is not present. You can see in the right hand side D is not present. Try with D closer. How to do closer? Here D closer, anything is not coming because D is not able to do any one. That's why D closer, anyone is not coming. Now you have to try with adding another attribute with D. If you are adding another attribute, AD closer. Now A to BC. So A, BC. Now B can do CFH. C already I took. So FH will come here. With the C, FH will come. After that what will be happen? Then you can see that with the F you can do EG. So you can do EG. Now with the AE you can A is already there. So all are done actually, you can see, and D is there. So that is D. So A, B, C, D, E, F, G, H all are possible. So this is my candidate key. Okay. Now you cannot stop here. Don't stop here. With AD you can try. A can be replaced with what? You can see that A can be determined by E. So A can be replaced with E. ED closer if you are doing, E can implies A, and after that everything will come. B, C, D, E, F, G, everyone will come. So that is done. Because E to A, after that the same sequence will be here. Then E can be replaced with what? E can be determined by F. So E can be replaced with F. If you are doing FD closer, then from F you can determine EG and E can determine A, and after that B, C, D all will be possible. That is also possible. F can be determined by B. It can be determined by B. So you can take B also. BD closer. If you are taking BD closer, then you can see that key B, C, F, G. Now it is possible that key, which one is possible here? F, G is done. Now F2, E is coming. Then after that remaining A, B, C, D will also come. So everything will come. Now after that B can determine by A. So already I completed it. Now all the candidate key lists are completed here. In this way you have to complete the list of all candidate key. That is your that is not fixed, Manisha. How long I will. So here it is A, D, E, D, all are done. So how many candidate keys are there? 4 candidate keys. So 4 will be my answer. What are the prime attribute here? A, comma D, comma E, comma F, comma B. These all are my prime attribute. What are the non-prime attribute here? Non-prime attribute is only remaining, that is A, B, C is remaining, F not G. C and G is the non-prime attribute, right? A, B, C, D, E, F, G. C and G is the non-prime attribute. So it is prime, it is non-prime. Now you have to check it is in which normal form. It is in which normal form, that you have to check. See that. Here is it in BCNF? This is not in BCNF because all the left hand side should be candidate key. This one is the candidate key. Any one is not the candidate key. So that's why it is not in BCNF. This is not in BCNF. Right? H is also the candidate key. Yes, H is also the candidate key. H, here also H is coming. Here also H is coming. Here also H is coming. Yes. H is also my non-prime attribute. So it is not in BCNF. Is it in 3NF? Is it in 3NF? 3NF means I have to check non-prime to non-prime. Is there any one non-prime to non-prime? Is there any one non-prime to non-prime? You can see CH implies Z. That is definitely non-prime to non-prime. This is CG, this is H. All are non-prime. So this is not possible. So that's why it is not in 3NF also. For 2NF I have to check is there any prime to non-prime. Here find out it. You can see this one. Here this one is actually I can write like B implies C, B implies F, B implies H. C is a non-prime attribute, H is a non-prime attribute. Right? So that's why these are not possible. So that's why this is not in 2NF also. So what will be the final answer? Final answer will be only it is in 1NF. The relation is in 1NF but not in 2NF. Clear? This is the way you have to solve the normalization problem. Okay. How you have to find out the candidate key. After finding the candidate key, you have to find out all the possible way, one by one check it, and after checking you can get the answer. Yes. So that's why your answer is in 1NF. I hope it is clear to everyone. I hope this is clear to everyone. Now tell me this one. First of all, tell me from this relation which one is your candidate key. Find out the candidate key and tell me which one is your candidate key. Is it only AB? Is there any other candidate key? A and E. Here just now this trick will not work. Here the trick will not work because right hand side all are present. If you are thinking that about right hand side which one is not present, everyone is present here. So trick will not work. Then how I can try? I can do the trial method, that is I will try with A closure first. With the A closure A, B, C, then B to D. After that C, D to E. C, D to E. So all are possible. So A closure, A is my candidate key. If I am doing B closure, so B, D, after that nothing is coming. So B is not my candidate key. If I am doing C, D closure, C, D, E, A, B, C, all are coming. So C, D is my candidate key. A is also my candidate key. C, D is also my candidate key. Sometimes students are doing mistake here. Ma'am, candidate key is minimal. So minimal to A, why C, D is minimal? See that, don't count the number of attribute. Don't count the number of attribute because here is not present. A is not present. A is a different attribute. C, D is a different attribute. You have to think that C closure, is it possible through the C closure you can determine anything? Or only through the D closure you can determine anything? No. That's why CD is also the candidate key. Minimal does not mean that count the number of attribute. Is there any common thing that is they are also able to do? No. That's why CD is also my candidate key. I will try with E closure. E to A to B, C, then D, all are coming. So E is also my candidate key. So how many candidate keys are there? A is also my candidate key. CD is also my candidate key. E is also my candidate key. These all are your candidate key. Actually, these all are your candidate key. Now you have to check. So this is in BCNF. This is also in BCNF. This is also in BCNF. But B is not your candidate key. That's why relation is not in BCNF. But is it in 3NF? So you have to think, is it non-prime to non-prime? No. Because what are the prime attribute here? A, C, D, E, all are prime. So D is a prime attribute. This is not non-prime to non-prime. This is non-prime to prime. It is allowed. In the right hand side, if you are getting prime, then that is allowed for 2NF also, 3NF also. Both are allowed. Okay. That's why it will be in 3NF. So it is in 3NF. So your answer will be 3NF. Is that clear? Is that clear to everyone? Yes. And my video stuck. This video is bothering me a lot. Where is the problem? I am not able to understand. Okay, it's clear, right? Okay, prime to prime means 3NF. Prime to prime also, right hand side prime means no problem. If the right hand side prime, then no problem. Okay, ठीक है. BC also candidate key. अच्छा, BC also candidate key. हाँ, maybe B2 B C D E A. This is also candidate key. Yes, you are correct. A B C C D E. B C is also the candidate key. You are correct. B C is also the candidate key. But D is also prime, right? So it will be what? It will be prime to prime. It will be prime to prime. So prime to prime, no problem. If BC is also candidate key, then B is your part of the candidate key, that is okay. But it is prime to prime. It is not prime to non-prime. It is not the prime to non-prime. It is prime to prime. So prime to prime is also allowed. Whenever in the right hand side prime, then that is allowed. Then there is no problem. Okay? Clear? Is that clear? Okay? Yes. Chalo. So normalization is clear, I hope. Normalization is clear to everyone. So now we will go for dependency preserving. Dependency preserving, equivalence and all. Equivalent, two things, two relation, two dependencies are equivalent or not. When there are two FDs, they are equivalent or not. They are equivalent or not. Tell me how to find out the equivalence. If this one from the FD1, if you are able to find out FD2, and from the FD2, if you are able to find out FD1, then they are telling equivalence. Both are equivalent. Okay. Tell me what will be the answer for this one. Ma'am, 3NF non-prime to non-prime and prime to non-prime, both are not allowed now, ma'am. Yes, but it was prime to prime, Rubella. In 3NF, non-prime to non-prime and prime to non-prime, both are not allowed. But it was prime to prime, right hand side prime, then no problem. It was prime to prime, right? So that's why there is no problem. Tell me, is it equivalent or not? Yes. So here what to do? First of all, you have to check AB no problem, BC no problem. Here the problem is AB implies D. That is not present here. So from FD2 you have to think, can I get AB implies D? Can I get anyhow? AB closure, do it. From AB closure you can see A is coming, C is coming, D is coming. So no problem. I can get AB implies D. I can get AB implies D. And now if you are thinking, so FD1, FD2 can cover FD1. FD2 can cover FD1. This is the meaning. FD1, FD2 cover FD1, FD1 cover FD2. So then both are equivalent. Cover means which one is superset. FD2 is covering FD1. Here FD1 is covering FD2. So here what we can write, FD2 is covering FD1. Now I have to think that FD1 is covering FD2 or not. So in FD1, from the FD1 there is ABCD, there is A implies C is not present and A implies D is not present. Now can I get it? Can I get it? Now you have to check from here. From here can I get A implies C? It was given A implies B and B implies C. From here transitive dependency I can get A implies C. That is okay. Can I get A implies D? Can I get from here? Here it is coming with the A closure. I am getting A, B, C, then D. Right? So that's why AB together is implies D. So A can come to D. So A implies D will be possible. That's why they are equivalent. Right? That's why we can say that yes, this is equivalent relation. Clear? Yes. Now next part is coming minimal cover. Which one is called the minimal cover? Minimal cover means what? Minimal cover means the extra attribute you have to remove. You have to remove the extra attribute, that is called the minimal cover. Extra dependency, extra attribute you have to remove. So come to the example and tell me what will be the redundant. From this question only you have to tell me what is the redundant dependency here. Just remove the redundant one. What is unnecessary? Unnecessary one, remove it. This is the dependencies given to you. Yes. So here the dependencies are A implies BC, D implies E, BC implies D and A implies D. Out of that, which one is not required, that I have to find out. How to find out? I can see here it is also implies D, here it is also implies D. Right? Both are implying D. Now whenever both are implying D, now you have to think that okay, any one of them can I remove? Try with one by one. If I am removing BC implies D, if I am removing that, then what is coming? Then you can see with the A closure, A, B, C, D is coming. D closure, D is coming. BC closure, only BC is coming. But previously with the BC closure, you was getting BC, D, E. So mean that I cannot remove this one. This is a mandatory one. This is a mandatory one. You cannot remove it. It's not possible to remove. That's why you cannot remove it. Okay. But here whenever you are coming to this one, that is A implies BC, B implies D, D implies E, then you can see that by removing A implies D also you are getting the same. What was in previously, after removing also you are getting same thing. So means this is the extra one. So the extra one is, this one is extra, unnecessary. So this is the redundant one. So I can remove this A implies D. That is the redundant one. Got it? So then what will be my minimal cover? If this is the redundant one, then what is my minimal cover? Yes, so definitely this will be my minimal cover because I have removed A implies D. Now here is A implies BC, D implies E, BC implies D. Yes, so A implies BC was there, A implies BC, that I can split in two parts, A implies B and A implies C. I can split it. That's why it is possible. Then BC implies D and D implies E. So it is the answer. Yes. So can you tell me which one will be the minimal cover for this one? Manisha, why you are telling 3? How the 3 is the answer? 3 is not the answer. How it is? Because it is given A implies B, A implies C. A implies D was the extra. You already remove it. How it is A implies D? You already removed that one. Now tell me what will be the minimal cover for this one? What will be the extra here? Yes. So here option A will be the correct answer because it is given to you V implies W, VW implies X, Y implies Vx and Y implies Z. Right? These are given. So out of that, which one is the irreducible? Means out of this I can remove the extra one. How I can remove the extra one? See that V can implies W. So VW implies X not required. Already V can implies W. So only I can write V can implies X. Already with the VW is coming. So that's why not required. Now from the Y already from the Vx is coming. If I am writing Y implies V, then already from the Vx is coming. So no need to write X again. It is extra. Then after that I can write Y implies Z. So all the extra we can remove. This was the extra, that is removed. And this was also the extra, that is removed. Because without that also we can generate VW. Here also we can generate Vx. So just remove that extra and you can get the answer. This is my correct answer. Right? Clear? Yes. Now come to the next topic, that is lossless and lossy decomposition. So here so many students are getting confused with the lossless lossy decomposition, how to do, what to do in lossless lossy decomposition. Okay, so I am telling you the story, and with the story, after listening to the story, here lossless lossy, there will be no doubt in lossless and lossy. There is a family and the family is now separated into two parts. In that family there is mother, brother 1 and brother 2. Okay, this is the family here. And here not only this, I am telling more, that is the, here in the family mother is there, brother 1 and wife 1, the brother of that wife, and brother 2 and wife 2 is there. Now they are separated, B1 with wife 1 and B2 with wife 2, they are separated now. Okay, now the thing is that if the mother is present between them anywhere, if the mother is present between them, okay, I will be the common people between them, here is also mother present, here is also mother present, then only they can join, because the mother can convince the brother 1 and wife 1, or the mother can convince the brother 2 or wife 2. Any one of them can be convinced. Any one of them can be convinced here. Okay. So that's why here this is the brother 2 and wife 2. Any one of them, if it is able to convince, then only the family will be lossless. Otherwise you cannot join, never, it is not possible. If it is like that, here is the family and brother 1 wife 1 is separated, brother 2 wife 2 is separated, and between them there is no common, no one is common, no one is able to convince them, then the family will not combine. Anyhow you cannot combine the family. That is the concept of lossless and lossy. After joining, is that lossless, or after joining is it lossy? So here this is the thing, you can come to this directly. First condition is R1 intersection R2 should be 5. R1 intersection R2 should be 5, should not be 5, means there should be at least the common person, that was the mother, at least the common person should be there. And R1 intersection R2 and implies R2 minus R1. What was happening? Here was mother, brother 1, wife 1, brother 2, wife 2. Now they are separated, B1 wife 1 and B2 wife 2. Now mother is here, mother is also here. Now what will be happen? Either mother, that is R1 intersection R2, either mother implies R2 minus R1. So this is your R2 and this is your R1. R2 minus R1 means the total minus the common part. So that's why it is B2 W2, or the mother, that is the common part, R1 minus R2 means the total minus common part. R1 minus R2 means the R1 minus the common part. R2 minus R1 means R2 minus the common part. So either this one, or it will be R1 minus R2 means B1 W1. So either mother can convince the brother 2 wife 2, or mother can convince brother 1 wife 1. Then only it will be lossless. Lossless means no loss in the family. If this is done, then it will be lossless, means there is no loss. You can join this. Otherwise, if mother is not there, if there is no common, or mother is not able to convince them, the brother 1, brother 2, wife 1, wife 2 not listening to mother, then also it will be lossy. It cannot be joined back again. Then that is called lossy. Is that clear to everyone? Is that clear to everyone? Lossless, lossy. Yes, I hope so. Is it clear? And another topic is coming about dependency preserving. What is dependency preserving? Whenever you are doing dependency preserving, so here how to do dependency preserving? Here I am taking the example of lossless lossy. You can see the example. This is the ABCD. Here this is the dependency given, and this all the relation are divided. After dividing the relation, you can see that how to check. Here between R1 and R2 you have to check which one is the common. B is the common. Now you have to check that key is this present. B is the common means either A implies B or B implies B. Common attribute, what is the common? So either B implies C or B implies A. Any one of them should be present. But here A implies B is present. Here only A implies B is present. But here B implies C is present. So no problem. That's why I can join them. Now common between this one and this one is C. I have to check either C implies D or C implies AB. So I can see here C implies D is present. That's why now I can join them together and I can get back the original table, that is ABCD. Original table I am able to get back. That's why this is lossless. And what about dependency preserving? This is the lossless, ma'am. What about dependency preserving? For dependency preserving, what you have to check? Always check the dependencies. Whatever dependencies was given to me, that is A implies B, B implies C, C implies D. After joining, after splitting them, can I get back? That is called the dependency preserving. Here you can see the dependency preserving, and always before dividing do the closure. Must do the closure before dividing. If you are not doing the closure, then you cannot get back it. It is not possible. Okay. You cannot get back it. So must do the closure. After that, divide it between F1 and F2. Then check it, the union of F1 F2. Are you able to get back F1 closure? If you are able to get back F1 closure, then only this is dependency preserving. Otherwise, anyhow it will be not dependency preserving. Got it? Clear? Then tell me, is this dependency preserving? Is this dependency preserving? Is this dependency preserving? Yes. So here first of all you will think that ABC, if I am dividing, then here is AB, here is BC, right? So here is A implies B, here is B implies C. But what about C implies A? You will think that, normally you will say that no, it is not dependency preserving. But what I told you, have to do the closure. Always do the closure in that way. A closure means you have to check here, in this way you have to check. A closure means you are getting A, B, C. Means A implies A implies B, A implies C. B closure means you are getting ABC. C closure means also you are getting ABC. Okay. So that's why Here it is getting ABC, ABC, ABC. Then distribute it. At the time of distribution, you can see here some hidden dependencies are coming, that is A implies B, B implies A. Here also hidden dependencies are coming, B implies C, C implies B. So all the hidden dependencies, whenever now you are doing joining, after doing the joining, your target was C implies A, can I get back? C implies A, you can get back from where? C implies B and B implies A. Here was C implies B and B implies A. This is the transitive dependency. Using transitive dependency, I can get C implies A. That is possible to get back. As this is possible to get back, that's why this one is dependency preserving. That is the reason it will be dependency preserving also. Got it? Clear? Yes. Why this is dependency preserving? So tell me what will be the answer for this one. Tell me what will be the answer for this one. Okay, answers are coming. Yes, answer will be this one. Definitely this is your answer. Right. Yes, answer is option A. Because here definitely all are, both are dependency preserving and lossless. Okay, this is also you know. So tell me this one. Do this one. Do this one. Do this one. What happened, Monica? What happened, Monica? Tell me. Which question you are confused? So I am coming. Okay, answers are coming. Yes, that will be, decomposition will be lossless. Why? First of all, you have to check that R was A, B, C, D, E. Now they are divided into two parts, that is R1 and R2. So here A, B, C, and here it is C, D, E. Right? They are divided into two parts. Now I have to check what is the common. R1 intersection R2 implies R1 minus R2, or R1 intersection R2 implies R2 minus R1. That is here. Now I have to say that yes, what is possible. So from here I have to check C implies AB or C implies DE. Any one them is satisfied or not. You have to check this C. In the C there is no duplicate. There is no repeating element. As there is no repeating element, so definitely C can determine A also, B also, and C can determine D also and E also. No problem is here. That's why it will be lossless. That's why the decomposition will be lossless. These are the types of question. Indirect question. Directly you know whenever dependency is given. If the dependency is not given, then how to do? This is the way you have to do if the dependency is not given to you. Okay? Clear? Is that clear? Yes. Are you okay? Are you okay, all of you? Can we go ahead? Can we go ahead? Are you okay? Okay. We can go ahead. Okay. Then chalo. So in ER diagram, whenever you are coming to the ER diagram topic, what is there in ER diagram? In ER diagram topic is entity relationship diagram. ER diagram in the database, there is entity, these are the weak entity, attribute, these are the key, composite attribute, multi-valued attribute, relationship, one to one, one to many, many to one, many to many. These are the attributes are here, right? Yes. So here whenever these are possible, then how to do? Here this chart is very important chart. How to represent, what is the diagrammatic representation, the images, entity set, this is entity set, relationship, this is relationship, weak entity, what is weak entity? Who don't have primary key, it is dependent on any other any other table. It is dependent on any other entity. Okay. So thank you Sharma. Weak relationship, when a weak entity is making the relationship with another entity, that is called weak relationship. Attribute we are representing like this way. Composite attribute, what is the combination of multiple attribute, that is called composite attribute. So composite attribute means here we can combine that is last name and first name. First name and last name you are taking, you can combine. Or address, you can take the city, state, street number separately, then you can combine. That is the example of composite attribute. Multi-valued attribute. What is multi-valued attribute? Phone number. Phone number, nowadays everyone have at least two phone number. At least two phone number everyone have. So that's why this is the multi-valued attribute. Derived attribute. Derived attribute means, and whenever there will be a multi-valued attribute in a ER diagram, then definitely you have to create a separate table. A separate table is required for a multi-valued attribute. Derived attribute, age. From the date of birth you are deriving the age. That is the derived attribute. Key attribute, that is your primary key. What is your key? Through the key you are identifying, that is called the key attribute. Partial key means when you are combiningly mapping the key with the two attribute, then part of that is called the partial key. Other than that, there are some key constraints: total participation, 1 to 1, 1 to many, many to 1. These are the participation. How to do the participation and cardinality? I am coming to you. Do this one. Tell me what will be the answer. Then I am coming to cardinality and participation. Do this one. I am coming with my water. Do this one. I am coming. Okay, answer came from everyone. Yes, this is your answer definitely. Where this is your weak entity, this is the multi-valued attribute, and this is the key constraint. Here this is the key attribute, and here this is the total participation. So how the total participation and cardinality I am coming here. Participation means minimum number of relation of an entity can participate. Minimum means one employee can work for one department minimum, and in one department there can be 0 employee also. Maybe it is a new department and there is no employee. That's why participation can be 0. When the participation is at least 1, means minimum is at least 1, that is called total participation, and we are representing the total participation with double line. This double line is the meaning of total participation, means minimum at least 1 participation is there. What is the meaning of cardinality? Cardinality means what is the maximum number of relation that one employee can work for one department only. That's why maximum is also 1. But one department there can be many employee. Multiple employee can be there in a one department. That is called the cardinality. And that's why here cardinality will be, this one is M. So cardinality is the maximum, participation is the minimum. And with here you can go for the key constraint. You can see the key constraint here. The key constraint meaning is here the cardinality 1. Meaning is cardinality 1. And whenever you are drawing any relationship, at the time of drawing relationship, be careful here. As here was the employee and here is the department. Okay. So employee is here, department is here. The relationship is coming with cardinality always, not with the participation. Always it will come with cardinality, not with the participation. So here the cardinality was 1 because one employee can work for one department only. That is 1. In one department there can be multiple employee. That is M. Right. So that's why what is possible, 1 will go in this side and M will come in this side. That will be now M is to 1. It is very important. Don't do this mistake. Always remember 1 is going this side and M is coming this side. That's why the relation is M is to 1. Don't tell that key relation is 1 is to M. If you are writing 1 is to M, that is wrong. Don't do that. Okay. So this is the meaning of this one. And how to get the one key, where is the key constant? If it is given like that, this is here. That is the meaning. Here the cardinality 1. The meaning of this key constant is, in the employee part cardinality is 1. That is the meaning. Now sometimes questions are coming on that how many tables are required. How many minimum number of tables are required for the diagram. This type of questions are coming in ER diagram. So for that I am telling you one trick. That is when the relation is 1-to-1 relationship. The relationship is 1-to-1. Then there will be, for this one table will be required, for this one another table will be required. And this relationship table you can combine with any one of them. Because here is also cardinality 1, here is also cardinality 1. Either you can do T1 R1 also, or you can do T1 R2 also, or T2 R also. There is only one relation. So either you can do T1 R or you can do T2 R. Means relationship you can add with anyone. If it is one-to-many, relationship, then what you can do? In one-to-many relationship, this is actually the one part and this is actually the many part. Always remember, you can add the relationship with the table where cardinality is 1. That is only you can add. You can add with the where cardinality is 1 with that one. So if this is my employee table and this is my department table and this is the relation, so the relationship can be added with the employee table only, not with the department table. Don't do the mistake here. Okay. For many to one also same thing. If it is many to one, then also same thing. With the cardinality 1 part only you can add the relationship. otherwise not. But if it is a many to many relationship, many to many means both part are here, this is the many to many relationship, then what will be happen? For many to many relationship, you have to create a new table. There it is required 3 table. Here it is required only 2 table. Here also 2 table. Here also 2 table. But here it is required 3 table. Because as this one is many to many relationship, you have to make separately. You cannot combine the relationship. It will be not able to possible to combine the relationship. Ma'am, why? You can ask me why. Because just think an example, employee department. Okay, think that example. Here many employee can work in one department, many department can have one employee. Now the relationship in the employee table, can I add like that employee ID and here is department ID? Can I do like that? Ki employee 1 is working in department 1, employee 1, 1, 2, 3 like that way. That one employee is working in multiple department. Because multi-valued attribute is not allowed. Here also can I do like that? Ki this is the department table. Here is the DID. Here is the EID. Department 1, employee E1, E2, E3. Can I do like that? That is also not possible. Because it is coming multi-valued. So that's why what I have to do, I have to create a separate table where I will do EID and DID. Employee 1 in department 1, employee 1 in department 2, employee 1 in department 3. Like this way I can create. That's why here the extra thing is required, that is the extra table is required. Otherwise you cannot do it. Is that clear? This is the main concept of ER diagram. But here whenever you are taking that ki okay, this is the employee table and this is the department table. In the employee table cardinality is 1, department table cardinality is M. Means this is the relationship many to 1. Then what will be happen? With the employee table, when there is EID, 1 name is A and then I can add DID because one employee maximum one department, that is D1. Employee 2B, it's working in department 2. Employee 3C may be working in department 1. That is possible. That is possible. Because here is the cardinality 1. Here is the no chance that one employee will work for multiple department. Whenever one employee is working for multiple department, then there will be the multi-valued. Multi-valued will be not possible. Can I add here? Here I cannot add. Because in the department there is DID. It is the department name and here is the EID. In one department there will be maybe employee 1, employee 2, employee 3. I cannot do that. Because here it is many. One department can have many employee. As one department can have many employee, I cannot do it. I cannot add it. That is the reason when it is 1 to many or many to 1, always remember you can add the relationship where cardinality is 1. Here many to 1 means cardinality is 1 here. That's why you can add in the employee table. Clear? I hope it is clear to everyone. Total participation, partial participation, everything is clear? Yes. Achha, tell me what will be the answer for this one. Quickly do this. Yes. So given ER diagram and relationship model, which one is incorrect here? That is, this one is incorrect, because in row of a relation algebra relation there will be more than one attribute. That is not possible. More than one value means multiple value. That is not possible. Now tell me what will be the answer for this one. Yes, here the answer will be D, because relational database schema represent the logical design of the database. That is correct, but current snapshot is taking only degree not, it will take the cardinality also. That is number of data. It is focusing on the number of data. That is the cardinality. It is given only degree, that is number of attribute. That's why this is wrong. Now tell me what will be the answer for this one. I am going on only. Yes, so what is the answer here? 4. Because degree of a table R, degree means number of attribute. Here whenever you are taking, there is the 3 attribute here. Here also there are 3 attributes. You are combining them. You are doing the cross product. So total 3 plus 3 will be 6 here. Cardinality means number of row. So here was 3 and 5. So it will be 3 multiply 5, that is 15. Cartesian product. After Cartesian product, it will be 15 here. Foreign key of the relationship table. What is the foreign key here? Foreign key will be for the student table foreign key. You can see in the student table roll number, name, course number. Here this course number is the primary key, this is the foreign key. So that's why definitely this is my foreign key. For the course table there is no foreign key. So that's why it is the answer. Yes. Achha, now I am asking you another question, that is a good question. Tell me this one. Number of table required, and what are the table here? What is the minimal number of table required here, and what will be the attributes in the table? What will be the attributes in the table? That is also you have to tell me. Okay, thank you. Thank you. Do your best in your NIC exam also. Oh, it is coming on 12th December. NIC exam. Do your best. How many table will be required and what will be the attributes? Okay, Monica, I will also end. I will also end because we have 6:30 class. So I have to also end. Yes, the 5 table will be required here because here is the key constant. These are the key constant here, right? So these are the key constant here. Whenever these are the key constant, then you can combine R1, R5 and R4 with this. So that's why these all are combined. And here what are the attributes are possible? B1, B2, A1, C1, D1. All are possible. Now you can see here also the key constant. This is also the key constant. So that's why it is the cardinality part. So I can combine the R3 with this table. After combining I can get this one. But this one is separate. So that's why for separate table I have to make. Here this is many to one, many. Because here there is no key constant means it is many to many. In the many to many I have to make a separate table R2 and here I have to take the candidate key of this one and this is the primary key of this one, that is A1 C1. And here this table is separate. So this is table 1, table 2, table 3, table 4 and table 5. These are the all tables are possible here. This is table 1, table 2, table 3, table 4 and table 5. Okay, these are the all tables are possible. Okay, in this way we have to, you can do it. Tell me this one. After ER diagram I have to end because otherwise I cannot talk in 6:30 class. I have a paid course on 6:30 p.m. and there I promise that we will do the compiler PYQs, compiler expected MCQ and PYQs. All MCQ we will do today. That is my promise. So I have to keep my promise also. So after this CR diagram and more than that I will be not able to possible. Other topic you are asking about B3, B plus T. It is there, already there. What is not there that much that I cover. Okay. So B3, B plus T topic, SQL, transaction, these are the recently I cover this all the topic and that is there. I will show you where it is possible. I am showing you, you can definitely go through it. So here it is 3 table because 1 to many, for that there will be 2 table, but a multi-valued attribute is there. As there is a multi-valued attribute, so that's why you can go for 3. Here it is 1 extra required. Yes. Now tell me how many table will be required here. How many table will be required here? Tell me tomorrow what you need. Tell me tomorrow what you need. I am planning like that way. Whatever is not available, where more thing is required, that is I am, and what is more important for your exam, where this time exam question can come, that is I am focusing. According to my prediction, this year DBMS will be more focus. DBMS, computer architecture, yesterday we covered those topic, computer architecture plus operating system. DBMS also we cover, and another topic is DS algo can be more question. Software engineering, so many classes are there, don't ask me more. So many software engineering classes are already there and I took very clearly. This year only I completed. Although these are also present, but in DBMS recently I was not taking that much class, that's why I arrange. Yes, here also 3 table will be required. Because why? Because you can see this is the key constraint, this is also key constraint. This key constraint is attached with this one, and this key constraint is attached with this one. That's why here your table will be M table. You have to combine M1 M2 with M3 with P1, because in this M table this P1 will be added, and P table P1 P2 separate. In the N table you can take the P1, because of this key constant is here in the N table. So N table will be like this. Okay, yes, so that's why it will be your answer. That's why it will be your answer, right? Okay. Okay. Debolina Banker's algorithm we cover in the paid course. Those who are there in the paid course, you are not coming to the paid course, you are doing blunder mistake. I am covering so many things in the paid course. Banker's algorithm we did. Please watch that. I think you are there in paid course, right? If you are there, then try to utilize. Okay, yes, so here this is the 3 table. This is the 3 table. Now this is the last question on ER diagram. Do this one. After that I will show you the remaining topic from where you can cover, that are also important, and quality classes are already there. I know that. I am showing you. More than that, time is not there, and I have to also take little bit rest to continue the 6:30 class again. Tell me what will be the answer for this one. Tomorrow either we can do TSC, or we can do DS Algo, or we can do AI also. AI revision also we can do. So whatever your choice. Tomorrow is 3rd. 4th and 5th we have to do throughout the syllabus some question. All the thing, definitely Devolina. Definitely. Yes. Okay. So here what will be the answer? Consider the ER diagram model E1 and E2 connected with M1 and Mn. Here draw this one. That is, you can see here Mn relationship. E1 E2 connected with M1 Mn, right? So here you can see this is M is to N relationship. Here is E1, here is E2, E1 E3, and E1 and E3 is connected with 1 into 1 is to many. So here is another relationship. With that relationship E3 is connected, and this is 1 is to many relationship. Okay, and here E1 is 2 single valued attribute, these are given, and E3 this is also given. Then the relationship not have any attribute, that is also given. If the relational model derived from the ER diagram, then the minimum number of relation required. What will be the minimum number of relation? From here, as this is 1 is to many, I can combine them as a relation. So from here 2 relation is required, and from here it is already common. From here how many relation? For this many to 1 I need another 1 extra, right? And this is 1 extra. So that's why total will be definitely 4. Definitely 4 will be my answer, because here I need one table, for this one I need one table, and for this one too many part I need two table. So 1 plus 1 plus 2, that is 4. To confuse you, they make it 3NF. It will be definitely in 3NF, because here are the attributes given. You can see everywhere there are two attributes. There will be no chance of non-prime to non-prime. There will be no chance. One will be the prime attribute, another will be the non-prime attribute. No chance of non-prime to non-prime. So definitely answer will be 4. They are making this type of stories to make you confuse. Read the story and draw the diagram and come to the solution. That is the simple one. Read the story, draw the diagram, come to the conclusion. Don't be confused. There will be no chance, because only two attributes are present. Whenever there is two attribute, then it will be definitely in BCNF actually. It will be definitely in BCNF, because one will be your candidate key, another one will be your non-prime attribute. Right, so definitely it will be in BCNF for two attribute, and here there is no chance. So that's why this answer will be 4. Is that clear? Clear to everyone? So I hope you understand everything about ER diagram, and your mind mapping about this subject is done. I tried to cover those subjects where you can get comprehension type question, and other topic already present here. Go to our channel Unify Study. Go to here, search the name Unify Study here. Unify Study, search this name and come here. Here you can come to this channel, and after that you can see this 45 days crash course. Already more than 90 sessions are there. All the sessions as per your requirement. Whatever sessions you need, whatever topic you need, as per your requirement, all the topic are here present. For DBMS, if you scroll down, then you can see the DBMS topic here. These are the all topic in DBMS. Normalization, functional dependency, serializability. This is the transaction topic. Serializability, transaction and concurrency, PYQS and SQL. This is the SQL question. Okay, here is the SQL. These are the topics are available to you. And other than that, B tree, B plus tree is here. AVL tree, B plus tree is here. So just visit this. You can see everything is present for you. And definitely visit our app also, Unify Study. Go to our website, visit it. You can come to the free mock test. So many free mock test of computer science is available for you. These are the all free mock tests are available for you. For the database, go to the database and attempt that mock test. The mock tests are available. And other than that, definitely you can utilize other mock test also. Okay. And if you are interested, you can join our paid course from here. These are the paid course. That is the recorded version will be available, because on 5th I am going to end it. Later again we will start new batch. So when you are watching, according to that it will be. Go to Google Play Store and install the app and rate and review this app. Unify Study, if you are giving rating, review, and if you are installing this app more, you are using that app more, then it will be helpful for Unify Study. Okay. Thank you everyone. Please like, share, subscribe and stay tuned with Unify Study. Utilize as much as possible. We are trying to put our 100% for you, and I hope you can also put your 100%. Right? Okay. Thank you everyone. Bye. Those what are the topic was in detail required, I provide it, and this class I will add in this course also, because here some missing thing was there that I have covered. So I hope after that there will be no doubt. Bye everyone. See you again tomorrow. And tomorrow, as you all are telling that key what you have to do, you all are asking about most of the AI, TOC, AI, DS algo. So we can do one thing, the all important algorithm revision we can do. It is AI also, DS algo also. All important algorithm related, data structure algorithm and related to normal algorithm and the AI algorithm also. Tomorrow will be the mind mapping of algorithm, what is related to your AI and what is related to your normal subject of data structure algorithm. So tomorrow this way our mind mapping will be done. Okay, all algorithm throughout our subject, what are the all algorithm, list of all the algorithms one by one we will revise the main points and complexities, and we will practice some questions so that all algorithm will be covered. Okay, that will be better, and I hope you will get the question from that area. Algorithm day we will dedicate tomorrow for algorithm day. ठीक है, all the algorithm we will dedicate. चलो, bye everyone, bye. We will meet again 6:30. Paid learners, 6:30 class will be there for compiler, expected question, all MCQ we will practice. 3 PM only tomorrow we will come, and 6:30 PM as we know MCQ practice is going on. I am